Good evening once again, everyone. So this is tutorial for the fourth one for derivative trading. This evening, I would like to address a number of things. So mostly now we are starting on the Greeks, and I'll spend a little time just trying to clarify some issues that were raised by you guys, and then the rest of the time I'm going to try and go through those questions. I think that is a very, very good way, honestly, for you to learn, and I know that from experience. In fact, I would even say that the tutorials for this course is closest to my idea of what a tutorial really should look like. And then I share the questions with you, you do them, and then we go through it, and then everyone learns something. Okay, so we're going to do that. But before we do, so just on the admin front, so I hope that by now you have all formed your teams, which is very easy for me to check. So let's have a look. Now, if you haven't done that, and if you don't do it by this weekend, I probably will just do it for you at random, okay? Now, I have received, it's Abhijit, right? Abhijit, yeah, so it's okay. If you don't have a workmate, I will get that, I'll fix that up. And it'll be just random. Most of you have done it, okay? So by the end of this weekend, okay, so please do that, otherwise I'm just going to do it. All right, and so as far as the calendar is concerned, so the next lecture is well, it's not Friday the 12th, that's already happened. You just add 7 to everything. Okay, so next lecture is next week. As I said, the calendar for this course is pretty regular, and the correct version of assignment number 1 is now been uploaded, so you can see the spec there. The due date will be February the 2nd at 1 p.m. please. So by the time you come to the lecture on Friday evening, we want everyone to have done their work. We don't want people to still be doing it, and believe me, some people do. Right? We don't really like that, and it's not good for you anyway. So this is the calendar. So today we are right here. Okay. Notice towards the end there are a couple of tutorials which unfortunately have to happen on Sunday because I have some private engagements I cannot get out of. Okay, but that's next month, so it's far away. Okay. Now I have started compiling a list of. So first of all, I recorded all the tutorials so far, 1 and 2 and 3. So you are free and welcome to go in there and review if you want to. I don't actually do that for every course. I don't do that for every tutorial either. I do it for this one because I am aware that some of the topics can sometimes be complex, and you listening to me, you know, it can be, I think sometimes you just need time to review it and think for yourself. That's why I'm doing it. Okay? So, so if you want to do that, feel free to do that. Okay? This is a comment that I made some time ago on relative value versus pairs trading. It was not from this course. Okay. Now let me just quickly run by you some useful comments on option Greeks. Okay, and these will be useful for you for the rest of this course and for the rest of your life if you want to be an option investor, not necessarily a trader, even if you just want to be in that market. Okay, so so delta, as you know now, I'm going to stick to a call option for now. Okay? So delta is just the change of the call option price when the stock price is changing. Okay, and it is normally represented as a number either between 0 to 1 or even 0 to 100. Doesn't really matter. Okay, as long as you know what you are doing. If it's 0 to 1, so obviously it will be 0 and then 0.2, 0.3, 0.4. If it's 0 to 100, it will take any number between 0 and 100. So if you use this system, then a delta of 0.6 is what you call 60 delta here. Okay, so both ways. So in books and in literature and textbooks, normally you find this notation 0.6. Okay, but when you in trader circles, I think we tend to use 10, 20, 30, 40. Okay. Now it is approximately 0.5 when an option is at the money. It is not exactly 0.5. Okay. And I can show you that just by, I will probably visit our friend optionprice.com practically every week now when we have this class. So an option where the exercise price, which is another word for strike price, and then the underlying price, that's the spot price. So this one is at the money, and I'm going to just wipe out the interest rates just to make it simple. Otherwise, the forward comes into play. So when you hit calculate, excuse me, notice the delta is somewhere around 0.5. It's not exactly 0.5. Okay? So if you know a bit about the Black-Scholes Merton option pricing formula, you would know delta is actually an extraction of the original actual option formula. But anyway, so I have here, so don't worry too much about the theory. Okay, this course is not about the theory. So it's roughly 50, it's roughly a half or 50% or 50 delta. You can call it any one of those. Okay, and it changes fastest when it's at the money, and it changes faster for short maturity. Are you okay with the last two bullet points? Okay, I'll show you what I mean by that. All right. So, where's my notebook? Okay, you guys are still sharing this, I think. Okay. Why is it so small? View. So I send an invitation email to all of you that you can now, I send out individual invitations to all of you via email. You should be able to see this notebook live pretty much without me doing anything else. Okay. So, yeah, somebody asked a question about page 43 of lecture, I think it was lecture 4, not 5 and 6. So I'll go through that in a moment. Okay. Now, what I mean by changes fastest when it's at the money is this. So, and I'm going to stick to a call option, although it is equally valid for put option. So for a call option, you know that it looks sort of like this, okay? Now, so here is when an option is deep out of the money and the delta is really quite close to zero. Okay? Now here, it's deep in the money and the delta is very close to 1. In fact, if you go all the way to outer space, delta will be 1. And the definition of delta is the change in the, like I said, I'm going to stick to call options, but it's equally applicable elsewhere, is when the option price is changing, when the stock price is changing, how much does the option price change? Okay, so if you have a delta of, let's say, 0.5, that means when the stock changes $1, okay, then the option will change by how much? 50 cents. Okay. Now, please remember the delta, and when I mention this, I run the risk of actually confusing you, but I think I need to mention it. Okay. So when you say the delta of something is the delta of an option is let's say 0.6. Okay. Let's just say 0.6. I just thought I would use a different number. Okay. So delta is 0.6. So what we are saying is if the stock price changes by $1, okay, then the option price will change by approximately 60 cents. Okay. Now what we are not saying is we are not saying that when the option changes by 1%, when the stock changes by 1%, when the stock price, the option price changes by 0.6. We are not saying that, okay? They are quite different concepts. This one is correct, this one is not, okay? Except when your stock price happens to be 100, okay? And you can really see that, and I need to point this out because although you may not even be aware there is that potential confusion, I have seen students, when they take an exam, they step into it because later on they don't remember precisely what it should be, okay? So it is not the second one, okay? Unless your stock price right now happens to be 100, okay? Now, just to show you it is not. So for example, if your underlying price now is 90, all right, so you calculate, and I still have, well, now the delta is quite small. Okay, so the delta is 0.76, okay? So that means if the underlying price goes to, let's say, 91, okay? So it's a dollar measure, So if the underlying price goes to 91, approximately what will be the call option price now? It's going to be around 28 cents, okay? And that, well, around 29 cents actually, because it's 21 cents or 21.3 cents to be precise, plus 7.5 cents. So that is around 20. So you can see that when the stock price has gone up $1, the option price has actually gone up by almost 30% because it's gone from 21 cents. In fact, it's gone up like more than 1/3. You know what I'm saying? So you cannot, or you do not talk in percentage terms. You go from point, so this will be the increase, okay? So together, that gives you 0.2289 or nearly 29. So to go, you can see, to jump from here to here, okay? So this is the delta, but you cannot talk in terms of percentage increase. This is almost a 33% increase. Are you with me? Yeah? So don't make that confusion, please. Okay? Now I know maybe you didn't even think of this before, but I can guarantee that somewhere, because especially people who do fixed income, and they start thinking about duration. Oh, 1% change in yield is a 7% change in price, and they start applying that here. No, you don't do that. All right. All right. So I was saying it changes fastest when it's at the money. So what that means is, so going back to this graph, well, you can imagine if your strike was 100, then here the delta is close to 0, and here it's close to unity, close to 1. Now, delta in the end is nothing more than a measure of, so the x-axis is the stock price, and the y-axis is the option price. So when you have dc by ds, it is basically the gradient or the slope. So at this point, I'm pretending this point is at the money. Actually, it's a little bit off, okay, somewhere here. So it is the tangent at this particular point, and this tangent, it will change. It's going to go like this. Are you with me? As the share price change. Now, what I am saying is, so it's rising in steepness, in steepness, but the rise doesn't really happen. Here, the rise is very, very slow, okay? And over here at the other extreme, it's already basically 45 degree, and it doesn't have a lot more work to do. So at both extremes, actually, the delta doesn't change very much. That's all I'm saying. Here, it's close to 0, and it will move. The delta will change very slowly. Over here, it's close to 1, and it will change very slowly. So it's actually in the middle. When you're in the middle, the delta changes quite fast. Is everyone okay with that? Sure? It's not hard, okay? So think intuitively. So don't worry about the theory behind it. You can see just by drawing a couple of pictures that this is true. Now the other point I'm saying is it changes faster for short maturity. okay? Especially when you are near the money. Near the money is not a term that you often find. So near the money just means you are basically you are near the strike. So near the money is somewhere around here, okay? Either you are a little bit in the money or a little bit out of the money, okay? Now, so I say here, it changes faster for short maturities. And you can really see that because if I now draw a darker line, now when it's shorter maturity, the payoff curve is going to look like this. All else being equal, the line, so let's say the original, the blue line was, 1 month. So the black line might be like one week or something, okay? So the blue line can be, what was I using? What color was I using? Not purple, dark blue. So this one might be 1 month, okay? Do you remember me showing you last time that in option pricing, if nothing changes, then over time, this line, this payoff, it gradually comes back down to earth. Do you remember us talking? That was last time. In fact, the graphs are still there. Okay, so we discussed this last week, and if you're unclear, you can go back to that. But I could actually, I could share with you something which would bring that point home. Just give me a second. So this one is now. So here is a typical simple call option as per the Black-Scholes option model, and so you've got different things that you can change. Like I'm not going to change the strike because I want to study an option with a strike of 100, so I'm not going to change that. But what I will change is first of all the time to maturity. So if you change that to 0, now you can see now you have that straight line that I was showing you last time. And now when I say all else being constant, this is the best way to show you what that means. All else being constant, I just move the maturity and I don't change anything else. You see how the line changes? That was my point. That was my point last time, okay? So this is how you can think of options, the way they evolve over time, pretending that nothing changes. There is a natural tendency for option value to decrease until you get to maturity and you get this classic straight line that you see, okay? So now, what was I saying? So it changes faster for shorter maturity. Now, why is that? Well, it should be quite obvious that if you look at the curvature, hello, good evening. If you look at the curvature, or another word for that is convexity, although that has a kind of fixed income or derivative flavor to it. Convexity is, in fact, that is another word for gamma. Okay. If you look at that, convexity just means how bent a line is, and you can see the black line is actually is far more curvy compared to the blue one. Okay, so it is not surprising that around here, the delta is rising a lot faster than the blue one. And this will show you much better, because if you look at time to maturity, if it's further away, you can see the line is actually quite smooth. So delta is still going from zero will be somewhere here, 0 to 1, but it's doing, quite slowly. But as you get closer to maturity, okay, it basically stays at 0 for much longer, and suddenly it just goes boom like that. Right? And when you take that to the extreme, let's say you are 1 hour before maturity, or something like, oops. Then the most extreme case, you imagine today is actually the option expiry day. And the spot price is hovering around 100. And it's going from 99 to 101, 99, 101, 101. So that can happen. Okay? Now, what then happens to your delta? It's flipping from 0 to 1, back to 0 to 1 to 0, isn't it? You know what I'm saying? It's an important point. Do you understand what I'm saying? Because here, when you are so close to maturity, your payoff looks like this, right? So when you are here, it's basically a flat line. When you are here, you are basically 45 degrees. So if you go from out of the money to in the money to out of the money to in the money, you are going from flat line to 45 degrees, back to flat line to 45 degrees. You are flipping back and forth from 0 delta to 100 delta, back to 0 delta to 100 delta. You know what I'm saying? Yeah? So it changes very fast, okay? So that's my point. Does anyone know when that happens? When it's flipping from 0 to 1, back to 0 to 1 to 0 to 1. And it's very, very hard to manage for traders. There is a term for that risk. Does anyone know what that term is? Yeah. Very good. It's called an English. Let's see. You need to scan on this. And then this is how I keep track of the participation. You just enter your student ID. It's called a pin risk. Hello. Hi. That's good. I'll use this one. That's called a pin risk. Pin as in PIN. Okay. Now, where was I? Okay, so now gamma is a measure of how the delta would change. And in fact, so I was saying to you here that when you look at any option, then at the extremes, the delta is actually changing very slowly, okay? delta is changing slowly. Now, that is also happening up here. The only difference is down there, delta is 0, and up there at the other end, delta is 1, but whether it's 0 or 1 or close to 0, close to 1, delta is actually changing very slowly. Okay? But here, around this area, is when delta is changing fast. Okay? So that is why when you look at a graph of the gamma, you get something like, so if this is, so I'm using the same scale, okay? So the x-axis is the share price. So gamma might start very slow, and then it goes up, and then it comes back down. Okay? That is the reason, because the delta is really, a lot of the action is just happening around this area as far as delta changing is concerned. And it gets most extreme when an option is close to maturity and you are close to being at the money, okay, because then when the delta will change from 0 to 1 and then 1 back to 0. Now, when a delta changes from 0 to 1, actually, what is the gamma in that case? So the gamma is the rate of the change of delta, okay, when the share price is changing. So when you are measuring the change, in this instance, when it's flipping back and forth between 0 and 1, okay, if you have a okay, in a more normal circumstance, okay, so let's say now here the delta is 0.5, and so that's the line here, okay, and then you move a little bit up here. So this is your new delta. Okay. See if I can draw that a little bit better. I really need a ruler. Okay. So this is the old one. Maybe I can use a different color. So the new delta is the red line. So it's gone steeper. Okay. And the way you measure that is by adding the gamma to it. Okay. So let's say, so the price right now is 100, and delta is 0.5, and the gamma is 0.02, let's say. Now, what does that mean? I'll tell you what that means, okay? So you've got two values here. You've got the delta value at a price of 100, and you have the gamma. Okay, so gamma is when the price changes by $1, okay, the change in delta is 0.02. So that means if the price moves to 101, then the delta would be 0.52. Okay, so that's what that means. Now, let me run by you some more. So by now you should be comfortable when we start saying that option delta is 50. So that means it's actually it's 50 over 100, okay, or 50% or 0.5. So you are dealing with an option which is very close to the money. And I think frequently you see in the lecture notes they start talking about long 10 gamma. So I have a portfolio of options, and I'm long 10 gamma. There is actually a mean, so it sounds like you talk about gammas like apples and oranges, but this long 10 gamma, it actually has some meaning, okay? And you have to relate that to this formula. So a half gamma ds squared, and I think you have seen, and we will come back to this again from time to time, okay? Now, if you have, okay, let me tell you what, for now, let me tell you what long 10 gamma actually means within the context of this course. You see this everywhere, okay? I'm long 10 gamma, I'm long 22 gamma. It means that if you are running an option position on something, so let's say a stock of Microsoft, okay, and if the Microsoft share price, it can be any stock, okay, or anything, but let's just say that Microsoft, and so that if I'm long 10 gamma, that means if the stock price of Microsoft changes by, let's say $2, let's just say $2, okay, my profit will be a half times 10, that's the 10 gamma, times the square of 2, okay? So you just plug in these parameters the way I have described to you, okay? So a half is a half. What is this? This is the long 10, okay? What is that? That is the price change, all right? Now, we'll come back to that later on, but I just want to let you know now, because some of you were asking me, what does it mean long 10 gamma, okay? Sounds like I'm talking like bananas and apples and oranges. So this is a dollar measure, in other words. Okay. Now I want to just very quickly also just to review with you this idea of the average delta. Now you actually see that in lecture number 4, and after we do this, we will come to that page 43 when someone actually asked me a question. Okay. Now average delta is this. So first, let me just go to that lecture. So when you go to lecture 4, and so somebody asked me to explain this what's going on here, but before we do that, there's this concept of average delta, okay, which starts somewhere around here. Now, this idea is rather, it's quite intuitive. Let's just say you have an option. It's hard to draw these. And originally, I'm going to be drawing a lot of these in this course. So originally, the price was here, or the option price, because originally the spot price was somewhere here. Now, and you know the delta at this point. In other words, you know what is the slope of this line. You know the delta here, and you also know the gamma here. All right. Now let's imagine, so in the next instant, the price goes to here. So now the price is S2. So the price has dropped a little bit. Okay. So of course your option value will be here. So you've actually gone from here. This is the change in your option value, correct? Because this is the change in the stock value. Okay? And the point about this average delta business is that if I have these two parameters, I actually can calculate what the price change will be. Going from, let's say you call this C1, and then you call this C2, okay? I can actually determine what is the difference between C1 and C2. Now, the first thing that you should notice is that using the delta is not enough, okay? Because delta is linear and your option price change is not. So that would not work, okay? So delta is an approximation and everybody knows that, okay? The second point is once you are down here, so you have a new delta. So I can call that delta 2, and you have a new gamma as well, although we don't actually need that for now, okay? Now the way you can calculate this price change, okay, is not to use the old delta, is not to use the new delta, but to use the average of the two. So the old delta where you started from and the new delta where you ended up, in other words, okay? Now, maybe you're asking, okay, well, Sam, I know what this is, but I don't know what this is, this one. Well, you kind of do, because you know what that is. You know what gamma is, and gamma will tell you how delta 1 will change when the price is changing. That's what gamma is about. Yeah, you understand that, right? So that's what gamma is. And so once you find out the average delta, this item here, okay, you can actually apply the stock price change to this average delta, and that would give you the option price change. Now, let's look at an example, okay? That's precisely what is happening here. So you start with a call option, okay, where the strike is 50 and the spot price also is 50. So there is the option delta. Now you can say this is 0.5 or 50, doesn't matter, okay? 0.5, so this one is 4 or 0.04, and the option value right now is 650, okay? So they're asking, well, if the share price goes to 51, what happens to the option value? Okay, now you don't know that to start with, but what you can tell is that the moment the stock price goes to 51, I know the delta, the option delta will be how much? Thank you, 54. Okay. So that means between 50, when you are traveling from 50 to 51, the so-called average delta is 52. It's just taking the average of 54 and 50. Okay. And now you can use this to determine the option price change. So you're going to add 52 cents to it. You do not add 50 cents, you add 52 cents. So that gives you $7.02, okay? That's where this came from. Is everyone okay with that? Yeah? Now, you can do the same thing from 51 to 52. So gamma remains unchanged. And now the delta, I know, will be 58 because it's 54 plus 4. So the average delta is 56. So I know the new price change, I just add 56 cents to it, which is going to be 7.58, which is what you see down there. Okay, now this is the so-called average delta method, and this is not some kind of coincidence. It actually has a geometric as well as a mathematical basis. I will share with you later on where that came from, okay? Maybe not today. So it's not just I drew some pretty diagrams and they look like they're symmetric. No, it's not that, okay? So now that we've done that, we can go to this example on page 43, okay? Now, what's going on here is as follows, okay? So first of all, don't look at these columns, okay? Just ignore them for now. And what you have is a put option, okay? And you are long the put option, all right? And you have actually, excuse me, you are long some shares, okay? Now, maybe I need to digress a little bit here and explain to you that you can be okay, so there's a call option, there's a put option, and you can be long a call, you can be short. Now, when you are long a call, we say that you are actually what we call long delta. Okay. Now, what does that mean when you are long delta? When you are long delta, if you say that to any trader, they would know what you mean. Okay. When you are long delta, so long delta means when the market goes up, all right, you are happy. That's what long delta means. Okay. Now, if you are long a put option, are you long delta or short delta? You are short delta, okay? What does short delta mean? So short delta means when the market goes down, you're happy, okay? Now, you can see what's coming because this very simple four-square matrix actually is symmetric. So the moment you figure out the top left-hand corner, All the other ones, basically you are just flipping them. So when you are short a call option, you are short delta. And when you are short a put option, you are long delta. Is everyone okay with that? Yeah? You don't really need to think, but I mean, you can go home and think deeper, but because I've got two offsetting products and I've got two offsetting positions, so these four squares, they have to be like this, okay? Now, the way option traders, the way they manage their positions, actually, quite often is when they are long a call option, so that means they are long delta. If you are long a call, okay, they are long delta. So what they would do is they would short sell a delta equivalent amount of stock. For example, if you are long a call option and the delta was 55, okay, then what they would do is they would buy one call and they would short 55 shares, because one call is normally equal to 100 shares, okay? So this is how this is now what you call delta neutral, as you've heard Govert talk many times. You are now delta neutral. So when in this case, in which case, so when the stock price goes up and you will make money from your call, because you are long the call, you're long delta, but you are short, you have short sold the stock, okay? So when the market goes up, you make money from your call, but you will lose money from your short position. So end up, you are what we call delta neutral, okay? So you are roughly, you are approximately immune from market movements. Now this is how option traders actually trade their book normally, okay? And you might be wondering, why do you buy an option and then you hedge out the main piece? And then you basically you are wiping out a lot of the excitement, which is the delta. Now, that is precisely what they want to do when they are trading options, because they want to trade. So you look at this is an option, okay, and now there are things that can change here, and there are things that cannot change, okay. So exercise price you can't change. Days to expiration, you can't change. Time is just ticking away, okay? Now, interest rates, we just assume it won't change for now, okay? Although when central banks are changing their monetary policy, it does change. But for now, anyway, traders have no control over that, okay? Dividend yield, just assume it's constant. So the only thing that conceivably can change actually is the price, which can go up, can go down, okay? And the underlying volatility, which is market driven, okay? That is 25 now. Tomorrow it could be 23. The day after it could be 27, okay? That is the price, that is how you price the option. Now, traders of options don't really want to bother guessing the price of where it can go. If it is 100 now, they don't really want to worry about whether it's going to go to 102 or 97 or 105 or 93. It's not really their focus. You with me? A trading desk for options does not care too much or as much about the actual movement of the underlying. Now, I'll tell you why, okay? If you're an option trader, right? And you have a call position, and you don't hedge, right? You don't become delta neutral, and you just trade like this. So when the price of the underlying stock is going up and down, then your option value is going up and down, isn't it? So now it's $6. So when the price sinks to 94, your option value will sink to 75 cents. So you are almost like a stock trader, okay? Because when the stock goes up, your option value is going up, and when the stock goes down, the option value is going down. So the guy who is running the option desk is going to say to you, well, if you trade like that, maybe you should just go and trade stocks, okay? So the stock trading desk is over there, so please go and join them, okay? So when you're over here, we don't want to trade that movement, which is why they would hedge it, okay? It doesn't mean that they don't like that excitement, they probably do, but it's not really their focus. So is everyone okay with that? It's an important concept, because unless you understand that, you got no clue why is it that every time there's a call option, there is another hedge on the back of it to make it delta neutral. Doesn't it make it looks redundant? Okay, well it is not redundant. It's there for a purpose, because that's how option traders actually make their money. Okay. Now, I want to tell you that because over here, you see something similar happening, okay? So here, so first of all, what is the position? Well, you are long a put, okay? You are long a put. So you can come back here. So I already told you, if you're long a put, what are you? You are short delta, right? So in order to hedge that, and that's why I explained to you a moment ago. So now you don't have to ask me, Sam, why are you hedging it? I already told you, okay? But in order to hedge this, you need to do what? You need to be long delta, don't you? Which means you need to buy stocks. You need to buy some stocks, okay? Are you with me? Yeah? Now, how much? It depends. So your option delta is minus 50, okay? Now, I can even explain to you what that means, okay? So that means, okay, so this is the put delta, okay? So when the share price goes up $1 up, okay? Is your put going to make money or lose money? If you are long a put and share price goes up, are you happy or not? Why not? Because when you buy, I'm sorry? It will gradually become out of the money, or it's going in that direction, right? Yeah. So you are not happy. And another way to explain why you're not happy is that when you are long a put, all right, you are short delta. So I already told you, when you are short delta, when the market goes down, you're happy. When the market goes up, you're not really so happy. Okay? So what you can do here is, so this means when the stock price goes up by $1, your put value will go down by 50 cents. Okay? That is why the option delta for the put is a negative value. Okay? So put delta is always negative, whereas call delta is positive. Okay? Okay, now the option value right now is $6.50, and the delta hedge is 50 because the option delta at this moment is 50. Okay, so that means if you have a put contract for 100 shares, put contract for 100 shares, then you are long, okay? You long a put. Then you need to buy 55 shares in order to become delta neutral. Okay, this will make you, sorry, 50 shares, I beg your pardon. 50 shares in order to become delta neutral. Now, please try to understand this point, because if you don't, then it's kind of hard to catch up later on. Everyone is okay so far? Yeah? So what you have is, now I keep saying put for 100 shares, and the reason I do that is I'm kind of used to the American market, where when you are buying shares in the American market, they deal in standard lot sizes, and I quite like that. So one lot, they make things simple, is equal to 100 shares always. In the Hong Kong market, that is not the case. It depends on the company. One lot is ISO, right? Lot size. So if you are talking HSBC, I think one lot is 400 shares. Some other different companies have different lot sizes, which makes hedging, confusing. But in the US market, one lot is 100 shares. And if you buy one put contract, it's put options also for 100 shares. Put for 100 shares. Now, that makes it really handy, because if I know that my option is 50 delta, so the delta is 50, I don't even need to think. I know I need to go long 50 shares. That's how that works. Okay? And that is what's happening here. So you just imagine that you now have this position. Okay? So in fact, they tell you here. So a contract size of 100. Okay, and the share price is $50. And then they talk in a per share basis. Now, look what happens when the share price goes from 50 to 51. Okay, now, first of all, what you have is you are long a put, and you are long some shares, but you are long put for 100 shares, and you are long some shares, only 50 shares. Okay? And when the price rises, so I'm not so happy about the put, but I am okay with being long shares. And if your option gamma doesn't change, then your option delta will go from minus 50 plus 4, which becomes minus 46. Okay? So that means the average delta is just between the two, which is 48. And I can now determine my option value. Now it starts at 650, and I know I have lost money. Well, how much have I lost? I have actually lost 48 cents. So my new option value will be $6.02. Okay? So I lost money on the option. 48 cents per option. So for 100 options, it's going to be $48. This is what I lost. Okay. Now on the hedge, so I am long 50 shares, as I said. Okay, and the price has gone up $1. So I have made $50 on this. So net, I've actually made $2. Can you see that? Everyone is okay? Now, you can take this logic one step further. The process is exactly the same. The only difference here is that the delta, the average delta is now between going from 51 to 52. It will be from 46 to 42. So the average delta will be minus 44. Okay? And that is why you are losing even more money now. Okay? And you have lost another 44 cents per option. So for 100 options, you have lost $44. But here, when the price was 51, your new delta is actually 46. Okay, so that means you are not, your long stock position has dropped from 50 to 46. And when the price goes up $1, you have made $46. So you are still 2 cents ahead. So sorry, $2 ahead. Okay. So it seems that when you are long option and you are delta neutral, every time the price moves, you actually make money. Now, I can even show you, and this is probably a good thing to do right here. So what if S was 49? Now it goes the other way. So this is not actually in the notes. Okay, let's see if we can figure that out. So first of all, your option delta is going to go the other way. It's going to be 54. Okay, so you can see the development, minus 42, minus 46, minus 50, so minus 54. Okay, so the average delta would be 52. Okay, this is the average delta. Bless you. So your option value over here is actually going to increase to $7.02. All right. So that means you have made 52 cents per option. So your P&L for the options total, you will make $52. Whereas your delta hedge, where you were long 50 stocks and the price has gone down $1, so you lost $50, you're going to end up making $2. It looks like whichever way you go, you make money. Are you with me? Now, isn't this wonderful? So why don't we all just do this? Why bother? Why go to college? Okay, just become an option trader, long a put, long a call, delta hedge, go back to bed. It isn't so simple, but what I can tell you is it is happening because of this. Okay, so let's say you were here before. So this was 50. And when you, I know I'm showing a call. I prefer call options because they're so simple, but it works just as well for puts. Okay, so if you are long an option, you're long the call. Okay, so you have to be short some stocks. So when you're long the call and the market goes up, you are making this money from here to here, whereas for your delta hedge. So this is your gain. In fact, this is your option gain. And this one will be your delta hedging loss. Hedging loss. You can see that because there is a gap between the gains and the loss. This will be this is that $2 that you saw. Now, the wonderful thing is when you go the other way, you get the same thing happening. So when you're down here, all right, you are losing money on the option. That's not good. Okay, so here you have an option loss. But guess what? I'm saying that if the price moves to here, okay, S2, this is S1. And then here, your hedge, now your hedge has a gain because you were short, okay? So if this is your loss and this is your gain, again, you're going to come out in front because you make this little bit here, okay? What is the term for that little gain, no matter whether you go up or down, which we showed an example here. This is exactly what's going on, okay? And here, I'm just showing it to you in a diagram format. This tiny little bit of money that you make because why? Because of this, because your profit is rising faster than your loss when it's going up, and your profit is falling slower than your gain on the hedge when it's going down. That's what's happening. Why is that happening? Because your option payoff is not linear. That is why. Okay? It will always be like that. As long as your payoff looks like this, okay, it's always going to diverge from the straight line. Okay? Now, so my question, what is that little gap? The money that you earn, the money that you get to keep, which is this $2 here. What do you call that? There's a term for it. Do you know? You need to know, guys, because that is central to this course. You know, if there is one thing that really is at the heart of this course, it is that idea. Okay, this is called gamma revenue. Okay, gamma revenue. You don't really need a lot of theory to understand this. All you need are two lines or a line and a curve. Okay? So I'm trying to boil it down to really, really simple. So you are long an option. Let's stick with a call. Okay, your payoff is a curve. So it's rising faster than a linear, a curve payoff is rising faster than a linear loss. A curve payoff is falling slower than a linear gain. That's all it is. Everyone is okay with that? Is everyone okay so far? Make sure you understand this, because if you don't, then you're going to get quite lost further down the line. Okay. Okay. Are there any questions, please? We still have about 5 minutes. I'm not sure what to do. I was hoping to go through those multiple choice questions, but maybe we don't have time for that. Is everyone okay so far? Yes. Yeah. No. That's a good point, actually. Thank you for raising that. Actually, when people are quiet in class, I am happy to record the participation even when they ask a question. So why don't you do another scan on that thing? Okay. Just give yourself a point. Yeah. Just put a one in there. Okay. Um, it's a good point, and I almost forgot to mention it. And you can see that there is a option gamma for I think they mention in the notes somewhere that this is, here we go. Okay, on slide 40, it says for simplicity, we keep the gamma constant in this example. In reality, the gamma of the 50 call will decrease if the share price rises away from the strike. I would even add to that the gamma will decrease, not necessarily rises away when it moves away. So when it goes either way from the symmetry of the strike price. Now, what does that mean in English? It means that, so the easiest way to understand this intuitively is just ask yourself, what is gamma? Okay, so gamma is the speed with which the delta of an option is changing. Okay, now let's say and I can show you very easily. Okay, so your strike price of a call is 100, and at the extreme, so let's say when the stock price was 20, or when the stock price was 180. Okay, now I know that delta would be close to 1. I know that delta would be close to 0. But not only that, it doesn't change a hell of a lot, but around here it changes very fast. And it does not change at a constant speed. Okay, that is the important point. The speed of change really picks up. So here it's, well, let's do a very simple pricing. Okay, so when you have an option where in fact, make it a bit more interesting. Make it 90 days option. So when the underlying price is 20, I doubt you're going to see anything on the delta actually. Okay, so delta is 0. It's not exactly 0, but it's very close. So when you go from 20 to 21, the delta will not move. Okay, from 21 to 22, the delta will not move, and the delta is not moving because the gamma is 0. So gamma is the parameter that determines how fast the delta is changing. Now, the same thing will happen if you type 180 here. Now delta is close to 1, and gamma again is almost 0. And if you go to 179, because gamma is 0, I know that the delta is not going to move. See, it's still 1. Now, this is quite different when you are at the money. That's when things actually get far more interesting, okay? So at the money, delta is 52.5. Now you have some gamma, and when I change the price to 99, what would happen to my delta, do you think? You actually can tell me exactly where it would be. What would it be? You just take 0.032 from 0.52, okay? So that will be 0.492. You see that? Okay, now it's Abhijit, right? Harsh, sorry, no, Abhijit is the other guy, sorry. To answer your question, actually, no, the gamma is not constant, and you can really see that. So that was an oversimplifying assumption that we are making, but no. Now, what was the gamma when the stock price is 100? It's actually 0.032, and when you go down to 99, it won't be 0.032. Well, actually, I need to go further for you to see the change. Huh? Maybe I don't need to go further. I just need more decimals. I guarantee you it is changing. Okay? It's just you don't see the change. Sorry. It's not precise enough. Okay, thank you for that question. Okay, so what we've done today is, so we had a look at the characteristics of delta and how it changes from 0 to 1, what it means to have 50 delta, when is the point when it changes faster or fastest, and what happens to delta when the maturity goes shorter. And we had a look at gamma, and we also had a look at what it means to be long gamma, and we had quite a substantial discussion on trading practice, how option traders actually manage their book and what it means to be long a call and then to become delta neutral by selling some stocks, okay? And then at the end, after we did that, we had a look at some of the lecture slides, especially page 43, and we went through why is it that you are making money on the way up, and in fact, I demonstrated that even on the way down, you are making money. So we explained what's going on in this graph, and also we explained the concept of, what was that? Gamma revenue, okay? So I think we had a pretty good session, and I'm gonna let you go now, okay? Is everyone okay? Everyone is quite happy? All right. We need to make some progress with those multiple choice questions, but we'll get around to that. Okay. So we'll get that done. Okay. Thank you, everyone. And I'll see you guys next week.